Okay, so today we are going to review Activity 17, where we learned how to solve systems of equations. We learned that some systems have no solution or infinitely many solutions, and then we also learned how to classify systems. So I'm just going to pick a few of these to go through. So first one that I want to look at is number 2. So solve by graphing, show all of your work, then classify the system. So system, remember, by definition, has more than one equation. So we're solving all 2 by 2 systems here. So 2 different equations. So I'm going to color code mine just to kind of keep them straight. Remember that there is a whole separate video for lesson 17.1, which is the one that goes over how to solve by graphing. So remember that there's more than one way to graph a line. So you don't have to necessarily graph it the same way that I did, as long as the actual line result looks the same. And as long as you have work, of course. So this first line, I am going to choose to graph using slope-intercept form because it's already written in the y equals mx plus b format. So when I look at this, I can say, okay, I look at this equation, I can see that m is 3, mx, so m is 3, and b is negative 4. So that means my y-intercept is negative 4, my slope is 3. So we always start with the y-intercept. So I go down 4 on the axis. Then I'm going to use my slope. Remember that 3 really means 3 over 1. So rise 3, run 1, which means up 3, right 1. So up 3, right 1, up 3, right 1. It's really important that you don't get lazy with your lines, that you continue to plot actual points as you go across, because when we're solving a system, if you get lazy when you're plotting the points, then you may miss the intersection because you just tried to continue it without actual dots. So make your dots go all the way off the page. You can see here that I also went down 3, left 1, because that's the same. Remember that lines that have a positive slope should rise to the right, and lines with a negative slope should fall to the right. So I'm done with that line. So now I'm going to look at the second equation here. And when I look at this, I am going to, because these are all even numbers and the number that's in front of the y is 2, I can easily put this in slope-intercept form. So I'm going to subtract 6x from both sides first, trying to get y alone, because that's what slope-intercept form is. The y is by itself. So that gives me negative 2y equals negative 6x plus 8. And now I divide by negative 2 to get y by itself. So negative 6 divided by negative 2 is positive 3, so 3x. 8 divided by negative 2 is negative 4. So m equals 3, b equals negative 4. Now, I notice this is the exact same m and b as my first one, which means that the line is exactly the same. I start here, up 3, right 1, up 3, right 1. So it is the same line, which means that the answer is infinitely many solutions. Now, the other part of the answer, it asks you to classify the systems. So remember that this in our station work was on the handout for station number 2. So I defined all of the classifications for you. When the system has just one line, we call those dependent. all dependent systems are consistent. So dependent and consistent there. All right, next, going to look here at number 4, so solving with substitution. Remember, you have typed out notes for all these things. You can go back and look at them if you need to, but make sure that as you are studying by practicing problems that you do it without the notes, because you can't use the notes on the quiz. So, first step is to pick one of the variables and isolate it. Remember that we said in the notes we want to choose variables that have a coefficient of 1 or -1. This coefficient is 2. This one's 3, 2. This is the only one that has a coefficient of 1. So this x is what I should choose to get alone. So to get that alone, I need to get rid of the added 2y. So I'm going to subtract 2y on both sides. So these cancel, and x is alone. X equals -2y plus 14. So step 1 is done. I've isolated one of the variables. Step 2 is to remove that variable from the other equation. So this is my other equation. I'm going to remove x. So I usually leave a blank parenthesis. Notice that I'm copying everything else about the equation exactly how it was. 2 plus 3y equals 18. It's just where the x was. I've got this parenthesis. And what I put in is whatever x was equal to. So in this case, -2y plus 14. Now I should be able to solve this equation for y because there's only one variable. So that means I need to distribute. So -4y plus 28 plus 3y equals 18. These are like terms. So -y plus 28 equals 18. Subtract 28. -y equals -10, which means y equals 10. Once we know y, our next step is to plug that back in to what we had from step 1. So now I say x equals -2 times y, which is 10, plus 14. So that's -20 plus 14, which is -6. So ordered pair answer, since that's what we do on systems. And then I need to classify it. So if I've got an ordered pair answer, that means that there's one solution, which means they are intersecting lines, which means that they have to be independent. In order to have just one intersection point, they have to be separate lines. So they're independent. Because there's a solution, that means that they are consistent. All right. Next, going to look at number 5. So elimination. First step of elimination is to line the like terms up in columns. So x's, y's, plain numbers, we're good. They're lined up. Now, the next step is to obtain opposites on one of the coefficients, so either the x's or the y's. So I always look, and so I look, for instance, at the smaller x and say, is there anything I can multiply this by to get the opposite of this? So is there anything I could multiply -2 by, so 2 times something, that would give me -6, because -6 is the opposite of 6. If I look at this, I would say, well, yeah, I could multiply by 3. So that's exactly what I'm going to do to get opposites. I multiply this top equation by 3. Remember that that means to multiply everything by 3. So -2 times 3 is -6x. Oops, got my negative kind of whopper-jawed there. 3 times y is 3y. -4 times 3 is -12. So all the terms got multiplied by 3. Next step is to add the columns together. Now that these are opposites, when I add them, the x's drop out. Now in this case, my y's also drop out, which means I just have 0 on the left. On the right here, I've got 15 plus negative 12, which is 3. Now, my variables dropped out. When that happens, that means it's a special case. You have to look at what's left to decide which special case. If it's a true statement, it's infinitely many solutions. If it's a false statement, it's no solution. So 0 equals 3 is a false statement, so that means that the answer is no solution. For classification, no solution would mean parallel lines, which means they're independent of each other. No solution also means that it's inconsistent, because solutions with a system are called consistent. All right, let's look at a couple on the back here. So, next one I want to look at is number 8. So solve by graphing. Similar to what I did on the front page, I'm going to color code this. Again, top equation already in slope-intercept form for me. So my m is 2, my b is negative 4. So that means start down 4, 1, 2, 3, 4. And I'm going to go up 2, right 1. So up 2, right 1, up 2, right 1, up 2, right 1, so on and so forth. Again, like I warned before on the other graphing problem, you want to continue the dots with the rise and run all the way across the page. If you stop it early, you might end up missing an intersection point. All right, next one. 2x plus 3y equals 36. If I want to get y by itself, that means first I need to get rid of this 2x. So I would subtract that. So that gives me 3y equals negative 2x plus 36. Then divide by 3. Remember, everything by 3. Negative 2 divided by 3 is just negative 2/3, so negative 2/3 x. 36 divided by 3 is 12. So it's now in slope-intercept form. The only problem is that 12 as an x-intercept is off the graph. And no, you don't just eyeball it and, continue along your way. You need to choose something different. I can see what the slope is, so that's helpful, but I need to find at least another point. So if I know that my y-intercept is 12 and my slope is negative, that means I should have points somewhere around in here. So you can just make yourself a t-chart if you want to try to find something that comes out evenly. So let's say I try to plug in 2 for x, which you can do in the original if you don't want to do with fractions, but you can certainly deal with fractions if you want. If I plug in x for 2, or 2 for x rather, in this first in this bottom equation, 2 times x is 4 because x is 2, so 2 times 2 is 4. 4 plus 3y equals 36. So if I subtract the 4, I get 32 divided by 3 does not come out evenly. So I might choose something different. I might say, okay, well, let's try the next number. Let's try 3. So plug it in again. 2 times 3, which is 6, plus 3y equals 36. So to get y alone, I would subtract 6. So 3y equals 30, which y is 10. So I do now have a point to plot. So I can go 1, 2, 3 to the right, and 2, 4, 6, 8, 10 up. So this is a point on the graph. You can use slope from any point. So I know the slope is negative 2/3, so that means down to right 3, down to right 3, Hopefully you already see where the solution is there. Remember, the solution is the intersection point, which is right here. So we look at that, and we see that the intersection point is at 6, 8. Because there's two lines, we say it's independent. Because there's just one solution, we say it's consistent. All right. I want to look next at, let's see. Let's look at number 11. Oops, and sorry, here you didn't have to classify it. On the front it told you to in the directions. I just did this out of habit. But if you didn't have those on these problems on the back, that's fine because the directions don't specify to. Alright, so last one, number 11. Elimination. So step 1, line up in columns. X's, Y's, constants. We're good. Next step, get opposites on one of the coefficients. So I look, ask myself, is there anything I could multiply 3 by to get the opposite of -9? Well, the opposite of -9 is 9. So 3 times what gives you 9? Hopefully you at least all thought in your head, if you didn't say it out loud, that it would be 3. 3 times 3 is 9, which would be good because we would have opposites. So I'm going to multiply that entire top equation by 3. There we go. Once I do that, then I'm going to add my columns. So the x's drop out. I end up with -8y equals -4. So divide by -8. These cancel. -4 over -8, two negatives make a positive, and 4 and 8 reduce to 1/2. So y is 1/2. Once I know y, I pick one of the original equations to plug it into. I'm going to pick the top one since its numbers are smaller. 3x minus 5 times 1/2 equals -4. So 5 times 1/2 is 5/2. If I add 5/2 here, remember that -4 in terms of halves is -8/2. Those are the same thing. It's not multiplication, it's just the same thing. So -8/2 plus 5/2 is 3/2, which is what 3x is equal to. And so then finally, -3/2, missed that, divide by 3, and I get x equals -1/2. So, list my answers in ordered pair. -1/2 is x, +1/2 is y, and again, you do not have to classify these ones. Please, 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 it's so important to study by doing problems. Redo ones on your notes without looking. Redo ones from the homework, from this review. But the only way to make sure you understand something is to do it until you can do it without making mistakes. All right, that's all.